There's a model that is able to reveal the origin of time. Very strange to consider what time actually is in terms of atomic physics. We have this kind of perceived reality that time is flowing in one direction and it happens in a sequential order of things. But in a fight, flight, freeze kind of response, time slows down. So how can time slow down? If you look at the issues around the frequency of things happening, okay, so just to kind of put you into a new framework, a new picture, considering the old PAL TV, 25 frames a second and 50 fields interlaced, right? So we look at a TV and we see a motion picture, but really nothing is moving. It's stationary frames or fields interlaced, played one after another very quickly in terms of 50 hertz. And that correlates to the mind being able to provide that information in a way that creates moving pictures. So the mind shows motion. And there's a underpinning physics that's happening within the person's mind that conveys that motion to that person. And when you look at the quantum features of the human mind, we're not talking about the conscious mind in terms of the neuron and its firing and the neurotransmitter going from the synapse and traveling across to the next neuron and making that one fire. We're not talking about the microtubules that others believe to be quantum elements in terms of providing a wave function and a wave collapse. Now, I'm talking about isotopes that inbuilt within the very structure of the atom is a time, a half-life, a half-time. So like a soccer game, you play one end of the game, trying to score a goal at the opposite end. And then at halftime, you change ends and you try to score a goal at the end that you were at, right? And so in a way, a game of soccer, a game of football is very much like an isotope physics process where half the time you're going in one direction and then half the time you're going in the opposite direction. And so this time reversal symmetry system that is operating is a game of football, except the ball in this game, the atomic game, the atomic half-life game, is the electron. And the electron's heading in one direction, and then it's heading in the other direction. And in one direction, it is considered to be negatively charged, and in the other direction, it's considered to be positively charged. So we have a half-life timing that is all about balance, the balance of opposites. So you get a dualistic perspective when you see both sides. And from the center point, you can see both sides. You can see positive on one side and negative on the other side. But rather than considering the sides of positive and negative being like left or right, or good or bad, or up or down, or back or forward, in that paradigm of opposites, consider for a moment a sphere, a bubble, and that the charge is on the surface of the bubble on the inside, and the charge is on the surface of the bubble on the outside. And what separates the inside and the outside is alpha, the fine structure constant. Now, considering the ability to turn the inside of the bubble inside out, so that the inside becomes the outside and the outside becomes the inside. And so plus and minus are interchangeable through the singularity within the center of the sphere, within the center of the bubble. That point that all photons point toward. And so it's a framework and a way in which you can understand the surface area correlates to an electron charge. And it has both an internal surface and an external surface correlating to an electron or a positron. And it really just depends on if it's been turned inside out as to whether the charge is minus on the outside or plus on the inside, or plus on the outside or minus on the inside. And so there's in essence, a balance there, a balance in a single particle that has both positive and negative. And now you have to decide what side you're on. Are you looking from the outside or you're looking from the inside? Are you inside out or outside in? And when you consider those dynamics of surface area correlating to a charge in coulombs, that you have to take into account both the inside surface area and the outside surface area in terms of how does charge relate to that 1.602 e to the negative 19 of a meter, the Coulomb charge on the electron, the Coulomb charge on the positron. I'm not even sure if people correspond surface area to charge. You know, the electron is considered a point light, point source, right? A point particle. So it is in essence a singularity. An electron is a singularity and it doesn't have a surface. But in the supersymmetry inversion model, the diameter of the electron corresponds to 4e to the negative 18 of a meter, and we can calculate the corresponding radius and therefore the surface area of the electron, both inside and outside, and see how that correlates to Coulomb 1.602 e to the negative 19 of a meter. So the science of measurement and the Compton wavelength of the electron is limited by the photon. The photons used to interact. And because the electron in the supersymmetry model is not measured, it's actually based on the inverse square law of the Planck length, 1.6 e to the negative 35 of a meter, square root of that for e to the negative 18 of a meter. And because I'm navigating the unseen through inverse square law relationships, it is just a foundational empirical theoretical framework in order to look at things mathematically, in order to understand the origin of electron charge as a surface area rather than a point particle. And it really provides an understanding of fundamentals, the fundamental constants of the universe. And if we understand the fundamental constants and their origin, then measurement really kind of no longer enables one to explore those fundamentals, because, you know, 13.8 billion years ago, there was this helium Bose-Einstein condensate, a Hebek singularity, he the father, he the king of creation. And from that perspective, we have to reconcile that, well, maybe science has this materialistic perspective that has missed something, and what it seems to have missed is hidden in the W boson, and what's in the W boson is charge, a charge carrier that helps the quarks flip. And when you explore the supersymmetry inversion model and you understand the origin of charge flipping, not the exchange of quarks within the nucleus, but the exchange of a positron with a nuclear quark, or an exchange of an electron with a nuclear quark. It is through an inverse square law mathematical calculation that one can understand tunneling and entanglement, how two of the gluons, or the gluon quark, is really inside the meson quark, and then the meson has a relationship with the electron and the positron. And that's why the spin, the orientation, or the entanglement that was created to begin with is related to the beta decay process, and why the beta minus, the electron release, and the antineutrino have that relationship that they do with their handedness and the W boson. So none of that science is accessible in the standard model of physics, because measurement breaks mirrored symmetry. It hides the positron and the neutron, and that's why the neutron's bigger than the proton. And it's only through a logic framework that you can understand mirrored symmetry, the symmetry of high energy physics that's responsible for half-life timings and time itself. Only through restoration of the missing piece of the puzzle can you correct the geometry of an atom into a framework that then reveals the processes that are responsible for actually forming the electron, the processes that are